you see that, well, you see that it's Paul and me doing a talk. You also see that we're going to be doing a demo on firevotes.web.app. You can join that at any time, and we're going to take you through some of the things in the live coding talk. But you also see a phone hidden in the back there. Let's actually look at what we have there. So this is a Flutter application that we have built. And as you can see, it's about the skill level that I probably have with Flutter right now, right? It shows hello world, nothing more. And what we're going to do in the next, let's see, 55 minutes or so is we're going to build this into a show of hands and audience polling app. Paul, do you think that that's reasonable? You think we can do that?
I think we could at least figure it out. So let's see. Probably the easiest place to start is going to be at the beginning. So let's actually open up the code for this Hello World basic Flutter app, which I just happen to have right there. All right, so when we're done, we'll want this app to have a couple of buttons that all of our awesome viewers could use to essentially raise their hands. And I think it would be fun to include some different rounds and a bracket to make this a bit more of a game. So our Flutter app has a few general components that we should be aware of. The main method at the top is where our app is going to start. This is where our My App stateless widget gets created and where we can pass in some general information to our stateful homepage, like app title and theme colors. Since the homepage is a stateful widget, it will also need to have a state object, which is where we'll do the majority of our Flutter work. In that state widget is a build method that will control what our UI shows on the screen. And right now you can see there's just this simple single text widget that says Hello World. So let's actually start off by removing that text widget and adding a new row of buttons. First, we'll add our row widget. This will let our buttons sit side by side on the screen. Next, let's add our first button to the rows children array. We'll start with an expanded widget so that the buttons will fill any available space. And that expanded widget will have a single raise button widget as its child. That raise button will in turn wrap a single text widget. And let's just go ahead and add the word yes to it for now. Great. Let's also add a background color here just to make things look a little bit nicer. So at this point, we can just copy that line and update the color and text over to the word no, and we'll have our second button. Great. Let's see here. Perfect. So we went ahead and saved this file, and then we can actually see that we have something that happened in our app. So one interesting thing to pay attention to here is that this code change, the change has updated the app without having to fully reinstall it. So this is a feature of Flutter called hot reloading, and it allows UI changes to take effect immediately while you're working in your Flutter apps. So now that we're back in our app, we can see that we have our two side-by-side buttons, but you'll notice that they're currently grayed out. You'll also see the same thing if you're following along in our web app. So this is happening because those buttons don't actually do anything yet. So let's go ahead and fix that by connecting these buttons over to our Firebase backend. So this actually seems like a case where the Firebase real-time database is going to be a good bet for both speed and simplicity of the data model. What's important to know about this is that the Firebase real-time database stores data in a JSON structure. So this is pretty much just a tree of values that's hosted in the cloud that our app's going to be looking at. If multiple users are running the app, they'll be looking at the same exact JSON at the same exact time. As far as the actual structure for our data, we'll want to work towards having multiple sections in our database. So that might seem like a lot, but that's totally okay. So let's first write a yes or no vote to the simple votes node here in our database. And then we'll build up to the final structure over a few steps rather than getting ahead of ourselves. We'll also want to look at our Firebase security rules to make sure that this data is readable and writable only by the people that we allow. So honestly, I'm not the best with security rules. So I'm going to just keep this simple for now and just stick to the default version that's going to come with a new database. We can come back to these later once we have more going on with our app. This is also definitely an area where I think we could use some of your help, Puff, to make these a little bit better than I could. All right, cool. So now that we've gone through our database structure and rules, we'll need to make sure that we link our Flutter app and Firebase project together. To do this, we've told Firebase about the package name for our Android app and the bundle ID for our iOS app. Based on that, Firebase has generated two config files that we added to our Flutter project. This is actually all done in the console, and we're actually looking at the in-console documentation page for this slide. So you don't need to worry too much about the details right here for now. What's important here is that these config files for our app are how we basically are able to tell it how to find our Firebase project on the server. We've also gone ahead and added our dependencies for Firebase into our Flutter project. So we're doing this using the Flutter Fire plugin here, which you can find out more about over on GitHub. So now that we're all set up with Firebase, let's actually go back to our Flutter project. The first thing that we'll want to do is initialize Firebase in our code. So what this is going to do is it's going to read the config file that we had added earlier and makes all Firebase services available to our project. We also created some fields here for all the variables that we'll need in our app. So now we can create a reference to the root of our database. So since Firebase is cloud hosted, if multiple users are running this app, they'll actually all be pointed to the same exact database. Great. And then for the next task, we'll create a new function called vote that will simply write whatever we pass to it into the votes node of our database. In this case, we'll pass in a simple yes or no based on the button that gets pressed. Looks good. Cool. Next, let's go back over to our build method and update our buttons. By adding an on-press listener to each button, Flutter will actually automatically enable them. Great, so let's go back to our mobile device and we can see that both of our buttons are now enabled. So let's actually take a moment to switch over to our database console as well. So this is the Firebase console for the database. And what you can see here is just the current content of the database. So one cool thing about this is that we'll also show updates live as they happen. So it's a great tool for us while we're working on our app. You're also going to be able to notice that we have a settings node here. This is actually something that we put together specifically for this demo. So we can just kind of safely ignore that for now. Now that we can see our database, though, let's go ahead and try voting. And that should have worked. Let's see what's in the log here. Right. So we actually haven't set up our security roles yet. So users aren't going to be able to vote into our database. So if you see, we actually have this permission denied here, and that should actually pop up as a little snack bar in the web app if you're also following along there. Puff, I think this is actually definitely an area where I think I could use some of your help.
Yeah, I'm not surprised, Paul. I get to do security rules a lot, but this is a great progress on the app already, right? We have the buttons. And one thing I also really like is that you started with a fully secure database, right? Sure, it doesn't make for the best demo yet, but at least nobody can write the wrong data into our database. So I actually think that's a great starting point. Firebase security rules are a bit unusual, but honestly, Firebase is unusual in that it allows you to write from the to the database straight from your Flutter application, right? So we need to do like some special work to make that secure. Let's actually switch back to the slides and see how we are going to make that secure. So here's the data model that we started with, right? We have a single node called votes, and we're going to write yes or no into it. And here you see the default rules that we started out with, right? Nobody can read or write anything to the database. Oh, let's first change that so that everyone can read the votes node. It's not strictly needed, but I sort of think it's a good idea here for the demo. Now, we need to make sure that people can only write yes or no, but we want to make sure that everyone can write yes or no. And we definitely don't want people to write different values to the database because we're showing it in the live stream. So the first thing we're going to do is we're going to add a validation rule. We're going to validate that the new data that is written to the database is a string, and that it's either yes or no. And we could have used a regular expression here, but honestly, I thought this was a bit more readable for today. So with that validation in place, I actually think it's safe to let anyone write to the database. So we're going to set write to true now. And this is the scary moment, of course. Let's publish these rules and go back to the database console and then see if the app now works. Oh, did you see that, Paul? Somebody is leading us to it. So you can see that now when we're clicking the buttons on the mobile app, it's changing. But when we're not clicking it, it's also changing. You see that? That's because the web application on firevotes.web.app is actually also writing this to the same location. But this is great progress, right? Now anyone can write to the database. but we're all overwriting the same value. Like there's only so much value we can get out of a single yes/no toggle. It's mesmerizing to see it change so frequently. Let's switch back to the slides and see how we're going to change the database model to make it more interesting. So we've created this initial data model. But what Paul actually showed us at the start of the talk was that we're going to use this data model. So we're going to store a vote for each user. So if Paul casts a vote, we see his vote, and if I cast a vote, we see mine. And we're going to see them as a list of votes. So we need to be able to sort of like identify that a vote is for a user. And for that, we're going to be using Firebase authentication. So Firebase authentication allows you to sign into your application by writing some Flutter code without spinning up any servers. So when you use Firebase authentication, your Flutter code talks to the Firebase servers to sign in the user, to verify their credentials. And then it gets back a ID for that user, a so-called user ID. And it doesn't matter what device the user signs in on. If they sign in with the same credentials, they're going to get the same user ID. So this user ID is great to associate data with that user. For example, their vote. So let's first change our security rules to actually secure this, because right now we allow everyone to write to the database. We want to change that so that only signed in users can write to the database. So we're setting a rule that's called auth.uid not equals to null. Now the auth variable is a built-in variable that's automatically set to the signed in user on the device that's causing the write to the database. So if we're signing into our Flutter app, then the auth variable will have our credentials in there. And we're checking that this user has a UID. This is automatically managed by Firebase for you. So there's no way for a malicious user to spoof this variable. So it's a great way for us to ensure that the user is actually signed in. Let's go back to the console. And let's have a look at where we are now, because we now have extra security rules. So can we still write to the database? Oh, I see that our error is back. And we didn't make any changes to the code yet. This is really good, because it actually means that we can't write to the database at this point because we've secured our database. This is one of the things I like about server-side security rules. You can make your app more secure without creating a new client-side application. That's really good for situations like this. Cool. Now let's go back to the code so that we can sign up authentication. So we're using Firebase anonymous sign-in here, and we're going to go to our init state to sign in the user. We're using anonymous sign-in because honestly, it's the simplest to wire up, because the user doesn't need to enter any credentials to sign in. It just generates a user ID for this user. We wait for that response to come back, and then we're going to set that user into the state so that we can use that for rendering the UI, or for example, for casting our votes. Now, once you're ready to further extend sign-in, you could also add sign-in with Google sign-in or Facebook, Twitter, Microsoft, LinkedIn, all kinds of sign-in providers, or maybe email password, whatever you want. But as said, for the demo, we're just going to use anonymous sign-in for now. Okay, but now when we click the button, let me switch the web demo over. We can see that we can still write to the, or we can write to the database again. So we've done a full circle now, right? We've gone from being able to write for everyone in the world to not being able to write, and now we're signed in so we can write again. So we've made our database a bit more secure. But we're still overwriting all the same data as before. Let's switch back to the slides and look how we're going to change that. So let's update our data model to the one that Paul had before. So we're going to store the user ID for each, or the vote for each user under their user ID. So that means that if Paul is casting a vote, we see Paul's user ID and then his vote. And if I cast a vote, we see my user ID. And if you cast a vote, you will see your user ID. You might not recognize it straight away, but it is yours. So we want to make it so that only Paul can write to his node. And if I write to it, that my write gets rejected. But we also want to make sure that Paul can't write to anyone else's nodes. So we want to make sure that we can only write to the node that corresponds to our user ID. Okay, let's see how that looks in security rules. So this is what we had so far. Everyone can write as long as they're signed in. That's what we need to change. We're first going to actually move all the data one level lower, because remember, we were writing to votes and then our value. We now need to write to vote and then our user ID and then our value. So you see that we added a level in our JSON in the rules, and it's called $UID. The dollar here has a special meaning because it means that the rules under this apply to any child node of votes. So this applies not just to one user ID, it applies to all user IDs that we have under there. You can see that we allow the write if auth.uid is not equal to null. We're going to leave the validate unchanged for now, but we definitely want to change that write rule. We want to make it so that the user can only write the vote under their own user ID. Can we go to the next slide? So we're changing the rule to say that you can only write if auth.uid is equal to $UID. And remember, that's the $UID that we also put in the JSON rules, right, in the JSON above. So these two values have to match, right? $UID is the variable that represents the user ID that you're writing under, and auth.uid has to have that exact same value. Okay, if we do that, it means that only Paul can write his value, and I cannot overwrite that one. And I can, of course, write my own value. Okay, let's go back to the code and make the change. Now, honestly, this was a lot more in data modeling than it is in code, because all we need to change now is our vote method. We're going to change it so that we don't just write to votes, but we're going to use the user.uid that we got from the state earlier. And that should be all we need to do to change the data model. Let's actually see if this works. Let's switch back to the console and click the button. Oh, let's open the votes. And I see, Paul, that lots of votes are coming in. I honestly don't know which one is yours anymore, but I'm just casting one on an extra device I have handy here. Hi. This is really cool. Thank you for playing along, everyone on the live stream. It's cool to see all these votes coming in. That didn't happen in any of the rehearsals. So let's see. The vote is now recorded in the database. And remember, there's no way that you can vote multiple times. You can change your vote, right? You can toggle from yes to no and you'll see it update, but you cannot vote for anyone else because your vote must be written under your user ID. You can try, but it will be rejected. Okay, I think this is actually pretty close to what we started with, but you know, I'm getting somewhat tired of all this yes and no voting. I really want us to be like a bit more expressive that we can do. So, let's switch back to the console and see if we can come up with something that we can change there. How about we store the values that we want to show in the buttons? How about we store them in the database? So we'll create an options node. And in there, we'll create an array of the values that we want you to vote on. So let's say that we use the colors for now. Okay, now we want it so that we display these values on the button, because that means that we can change the values without having to change the code. Of course, we first need to make that work in the change of code. And this actually is going to be reading from the database. So let's switch back to slides to see how that works in Firebase. Because we're now going to be using the most unique feature of Firebase's databases, which is we're going to use real-time listeners. With most databases, if you need the value from a database, you're going to like get the value and then just forget about the database. With Firebase, it's different. With Firebase, you're going to attach a listener to a location in the database. And that listener immediately gets the value just like you're used to. But it then keeps listening. The Firebase SDK actually keeps an open connection to the server, and it waits if there's any updates to the value. And if there's an update to the value, it's sent to your client, to your app straight away. That's what you see in this animation. You see that one of the devices is making a change in yellow, and that the change is broadcast out to all other connected devices within milliseconds. And this makes it effortless to build real-time, multi-user collaborative applications, or an audience polling app like we're doing here. Okay. Since we can now respond to these changes to the database in our app, this is called reactive programming because we're reacting to the database. And it's the key to making very interactive dynamic applications. Okay, now let's see how we wire this up in the code. We're going to go back to our init state method. We're going to create a reference to the options node. Remember, that's where we put the array of values. We're going to listen to the value of this node. And this is a stream. If you've done Dart stream programming before, listen gives us a stream. And In that stream, we have a snapshot of the values that currently exist in the database. And since it's an array, it actually is going to be a list of strings in our Dart code. So we get the options from there. And honestly, it's a bit of typecasting that we have to do here. But it's fairly standard. Now, for now, let's actually just print them, because honestly, I'm not very good at Flutter. So let's just print them and see what happens. We got an error. Let's try it again. I think we might have not updated security rules yet. Cool, there's the values that we have. And these are the values from the database, right? Orange and blue, because that's what we entered. And we didn't type orange and blue in, oh wait, we did type orange and blue in the application code. We could have like sneakily gotten it from there. And I know that we didn't. How about we go back to the console and prove that we didn't? Because remember, the code is still listening on the database. So if we change the orange to, let's say, yellow, you actually see that that shows up straight away. And in the web app, you should now have gotten a snack bar with the new values also. Now, this is reactive programming, right? We only wrote one statement to listen to the value, but we get called when that value changes. I think that's pretty nifty, actually, right? Paul, as I said, I'm not good with Flutter. How do we get these values onto the buttons?
I mean, let's take a look. So now that we have our options being populated, we should be able to do something with them. So what we do here is call the setState method in our Flutter code to force the app to redraw with our new data. You'll also notice that we already added two strings to our class, option 1 and option 2. Next, let's go into our real-time database listener and call the setState method. In there, we'll save the values from option 1 and option 2. Cool. Let's see, so finally, let's go back into our build method and use these options for both our display text and our voting values. One thing to pay attention to here is that we're using these like double question mark syntax. So if our option strings are null, like when we first start up our app and they don't have any data being pulled down and whatnot from the database, then we can just default to these 3 dots as an easy placeholder and more importantly, not crash our app. Looks good. Oh, maybe. We are missing a semicolon somewhere.
We are. Got it. Yay, compilers.
There we go. And see, and we can actually see that this is updated in our app as well. So for those of you that are following along, you should also see the buttons in the web app also update. So now that we've refreshed everything, looks good. We actually see yellow and blue instead of our hard-coded yes or no values that we had earlier. So while this works for our most basic functionality, we're still really only looking at one set of possible values. So Huff, maybe this is an area where you can kind of help us flesh this out a bit and make it a little bit more interesting.
For sure, Paul. I am sort of like, I'm a geek. Things must match up. That yellow is driving me nuts because the button is orange. How about we change it back to orange?
Yep. There we go.
Cool, thank you. I see the votes are still going on. That's also really cool to see. I think this is turning into a really fun voting app, right? An audience polling app. I actually, like everyone can cast their own vote. We can like control the question that we ask. I honestly could see myself using this already in my talks, but I know I'm going to ask multiple questions, right? I'm going to have a few probably yes/no questions at the start, and then some like more questions about, hey, do we do A or B later? And I'd like to keep the history of what I asked and what people voted on. So I think what we need to add now is add some rounds to this. Let's have a look at the data model in the slides for that. Okay, so we're going to move the options into a node called rounds. And we'll give each round a key in there. We'll see what the keys looks like in a moment. But so this way we can store multiple rounds. Now, under each key, we're going to store the values in an array, just like we did before. But in this case, I really like it. We can also show more values, right? So we're going to allow you to add like any number of values in there. And that creates an interesting choice that we have to make, because how do we handle this in our UI? Right? We have like 2 main options, I think. We can either show a button for every option in the database, or we can pick 2 options to fit on the buttons we already have. And for today, we're going to do that last one. We're going to pick 2 out of these options, but you can make another choice. That's totally fine. Now, since we added rounds, we also need to add another layer for those rounds under the votes, right? So remember, we had votes, user ID, and then your value. We're going to change that to votes, round key, and then your UID, and then the value. Now, see that these round keys match up. So we have round 1 key under votes, and it matches with round 1 key under rounds. That's important because it's essentially what a foreign key would be in many other databases. So we are making sure that these keys line up. Then under each round key, we store the value and the UID, right? So for each UID, we store a value. There's an interesting change that comes from this, because remember, you could only vote once so far. But when we do this, you can actually vote once per round. That's exactly what we want, right? If we start a new question, we want to make sure that you can vote on it again. Okay, let's see how we're going to secure these. Let's first look at the rounds. Let's see. I don't think we need to give anyone permission here to read or write. So we're going to set the read and write to false for the rounds. Oh, we're going to set the read to true, apparently, which is also fine. We can all read all rounds. But we're going to set the write to false. And that means that we can't write it from anywhere except from the console. So the Firebase console, since we're logged in as a collaborator on the project, we can make changes there to the database, even if the rules don't allow them. And that is great because that's what we've been doing so far in the demo. Now, I also want to say something about the rounds. And like I said, when we make changes in the console, it bypasses the security rules, but I still like using them as sort of documentation of my data model. So we're going to say that under rounds, we have a $round. Remember, that's dollar means that it applies to each child node of the rounds node. And then under that, we have $option, which is the options that we have in there, one item in the array. We're going to validate that that's a string, because honestly, that's all sort of that we know right now. But I still think it's useful to have this here. Then we're also going to add what I think is a nifty rule for securing the reads. So instead of allowing you to read the entire rounds node, we're going to allow you to only read the last item. But since we're going to be adding rounds dynamically, that last item is also dynamic. So you need to query for it. What this security rule does is it checks whether you're using the right query. Now, the order by key and limit to last, it doesn't really matter what they are all that much right now. We'll see them in the code. But this ensures that you can only read the last round. Okay, so this is the data model that we're going to be creating. Let's make that a bit smaller so that we can use it for reference while we're building the rules below. Oh, I didn't mean to make the slides so smaller. So okay. There we are. That's great. Okay, so remember we have we have votes, round key, user ID, value. So these are the security rules that we have so far, right? We have votes, user ID, and then the value with the write and validation rules. Let's first add a level for that round key in there. Now we're going to call this $rounds, and remember that means that it applies to any child key of votes. So we now have 2 dynamic nested levels here. We have the round key and the user ID. And we need to make sure that these match up somehow, right? So $rounds under votes matches with the round key, and the user ID matches with the user ID. But we want to prevent our database from being overrun with just any votes, right? We need to control the rounds that you can vote on. So we're adding a validation rule here that checks whether the round that you're voting on exists under rounds in the database. You see, we're going back to the root of the database, and we're checking if the round exists there. If they do, the vote is valid. If they don't, your write gets rejected. This way, we have some control over what you're writing in the database. In fact, we have quite a bit of control over what you're writing in the database. Okay, with the data structure decided and the security rule in place, I think we're ready to switch back to the code and make everything work. Now, we are listening to the options node so far. So let's change that to start listening to the rounds nodes, because that's where we now store the rounds. And let's see, we need to listen to the most recent rounds. So we're going to order them by key. This means that we must make sure that if we add a new round, its key is alphabetically later than the previous key. We'll see that in a moment when we start testing this. We're going to limit it to only get the last key. And we're going to listen to onChildEdit instead of onValue, because we only care about that one child. So let's see, this gives us a snapshot again, just like before. One thing we need now, though, is we need to get the key of that round, because we need that to cast our vote. So we're going to get the current round key from the snapshot. We're going to put that in the state so that we can reference it later. Now we get to probably the most complex line, because remember, we could have more than 2 options. So we can't just do option 0 and 1 anymore. We need to actually determine which options to show. And I have one thing that I really like. I like having pairs of options. So I like it if we have 4 options that we either show the first and the second, or the third and the fourth. So we're going to do some random magic here. We're going to determine the index of the votes that we want to show, of the first vote we want to show. We're going to do that by getting a random value between 0 and the length of the options we have, dividing it by 2, or actually shifting it left. This gives us a value if we have 4 options as either 0 or 2. So then we set option 1 to either options index or options index plus 1. I hope that makes sense. As I said, this is probably the most complex code. Okay, I think we're ready to get started on this, Paul. Let's switch back to the database console and start making some rounds. Let's actually first get rid of the options, because I don't like leaving old data behind. Okay, so we're going to create a new key under the root called rounds. And in there, we're going to create our first round. And as I said, this key needs to be always incrementing. So we're actually prefixing it with a exclamation mark here, which honestly is just something that's very early on in the ASCII chart. Now, in that round key, we're going to store an array of values. Let's see, let's just do something like numbers here, maybe. Right. Not very exciting yet, but let's see. Okay, I see that the web app on firevotes.web.app is working already, but I think we might still need to restart our Flutter app. There we are. Okay, so now the Flutter app got all options and it's showing option 1 and 2. And if you're on the web app, you either see 1 and 2 or 3 and 4, and you can vote on them. Now this is Firebase. Remember, I can see things happening already. We'll get to the totals in a moment, but I can see people are voting. Let's actually have a look at the votes for a moment also. Ooh, I like this. Do you see the round 1 key? Actually, Paul, do you see we have lots of old votes in there? Let's delete the votes key and let it just recreate for now. Okay, here's the current votes coming in. This is awesome. I like this. And you can see that you're all voting on the actual values. I feel very comfortable showing this data because we've secured our database. We're getting an interesting error, by the way, in the Flutter app. We'll see what this is in a moment. Don't expect to get any more errors there, so we'll see what happens. Paul, how about we do another round? How about we vote on, let's see, how about favorite programming language? That's not at all a contentious topic, right? So let's create a new child key called exclamation mark round 2. And we'll put an array of programming languages in there. Now you see, by the way, that Firebase stores these differently than we enter them. This is how the real-time database stores arrays. Honestly, it's just a fact of how it works. And you can see that the votes are coming in and that we're getting, can you show the votes? For round 2. And we're voting on our favorite programming language, excuse me. That's pretty cool, actually. I actually know why our code doesn't work, Paul. This is definitely a near miss. We've got to change our vote method. Remember, we changed the security rules that you can only write under round.userid, and we forgot to actually cast to a current vote. Let's change that here. Let's write to current round key /userid. That's a lot better. Now let's reload the app and see if we can now also vote without an error message. Thank goodness, no error messages anymore. And I assume that one of these user IDs is ours. Wow, that was a lot. I'm happy that we got everything working. I'm actually quite proud. But Paul, you've been showing that totals key, and I have no idea where it comes from. And honestly, pasting questions into the console is not really scalable. Can you show us how to improve that and where those totals are coming from?
Yeah, so rather than typing in the items that we can vote for every time that we want to run a poll, what we can do is put some preset items in a new script using Firebase's admin SDK. So I'm actually going to switch back over here to the slides. There we go. So here we add some options that we might want to vote on in a Node.js script. So instead of typing them into the console, we predefine them as a list in this script. We've actually initialized the script with a set of credentials too that we've already downloaded from the Firebase console. These credentials allow the script to run with elevated permissions, meaning it can write to our database and bypass the security rules, just like if it were one of us typing directly into the console. And this is the rest of the admin script. So what we do here is we set up a reference to the correct node in our database, select which options we'll use for the option, and then write them out into our database. So for our purposes, the code in the script isn't really that complex, but the fact that we can automate a bit of our database is the main takeaway here. So now that we have this put together, let's go ahead and go back to our database console and see what happens when we run this script. And I'm going to just go ahead and shrink some of this to make things a little bit easier for us to read. And let me switch to our terminal. Great, so it looks like our new items from the script have shown up in our database. So I'm gonna go ahead and just expand the new round. And there are 8 options, awesome. So you might also have noticed that these keys look pretty random. So they're actually coming from calls to the push function in our code, which automatically ensures that the generated keys are unique and always incrementing, which is part of why we ended up alphabetizing everything and pulling down the last one. So this is gonna be the case even if we have thousands of users writing to them all at once. And then after we ran the script, you can also see that we had that totals node that Puff had noticed earlier. I'll just go ahead and kind of expand that a bit here. Great. So let me go ahead and switch to our slides. You might be wondering where this is actually coming from and how it's being calculated. So this totals node is actually not coming from our Flutter application, and it's also not coming from our admin script. Instead, this is coming from a cloud function. So cloud functions are these nice little snippets of Node.js code that you write and that run on Google servers in response to events that happen in your Firebase projects. So for example, when a vote is written to the database, we can automatically run our own code to update a counter somewhere in our Firebase database. Because cloud functions run in a trusted environment, you can also be sure that only your code can update the totals and not just some random user that's out there. So let's go ahead and take a look at the code that's actually running these nodes. So this is the code that counts the total number of votes in our project. We can see that here that we have the function that is listening for any new votes created within a round. When it catches these new values, they're read into a new variable. And then we create a reference to the totals node where we'll write our new count. And then finally, what this is going to do is it's going to write the incremented value into our totals nodes in that database based on the vote, which is how we actually keep track of which items are ahead of others. So this only runs when the votes are initially cast. If you change your vote, it won't count the new vote. Now, we could change our security rules to only allow casting an initial vote and then rejecting any updates, or we can change the cloud function to allow the users to change their mind. Either way, between cloud functions and our security rules, we make sure that the behavior is correct and secure for our use cases. Great, so everything seems like it's working. Puff, what do you think about running a couple polls for everyone that's watching just so we can kind of see how this is going to work in practice?
Oh, I love that. And thank you so much. This actually really helps a lot, right? Between the admin script and the cloud functions, we've automated a lot of the things that during the talk we were doing in the console. And that is good because we're now going to be running a few quizzes because this might be the first virtual talk of my future, right? So this is the moment I'm going to be using this. Actually, Paul, can you switch over to the web app? And so this is what your web app should look like. You might see different button values, but you should see the same. There's like a show bracket button. Let's click that. Okay, so we're actually running little mini tournaments called brackets over here. So we're showing the results in the brackets. So if you were playing along on the demo, you would actually see that your buttons change much more often than when we put something in the database. And that's because we're automatically starting new rounds. So we're running a tournament over 8 values initially, it seems, and we're asking people which of these two is your favorite. So if you look at the outermost brackets here, you see that on the top left we have C or C++ versus JavaScript. And on the bottom right, we have Go versus C#. You can see the winner of these two, right? Who won? And the winner of each pairing is moved to the next inner bracket. So there we have JavaScript versus Kotlin, and Dart versus C#. Now, we determined the winner of that one, and that then made it to the final round. And that's the round that's currently still going on, because the final round doesn't end. So it seems that JavaScript is by far the favorite. That's not too surprising in this audience, even though I also like C#, by the way. I love TypeScript and C#, I must admit. So that's awesome. Now, we didn't really see what happens. So I'm going to run the same bracket again, the same thing we did before. Now we're going to start from the start. So I'm going to hit enter, and you'll see that it takes a moment, that the bracket now cleared. And now we're in round one. So you're seeing one of these pairings and cast your vote. Okay, so we have at least, there's no 0. That is good. I like that. So let's see, Dart is more favorite than Java. That's not surprising. JavaScript wins from C++. Kotlin is very popular, and Go. Honestly, we could have drawn this out on a napkin, right? But let's see what happens if we get to round 2. So it's now JavaScript versus Kotlin and Dart versus Go. And just cast your vote. I have no control over this, but the totals function that Paul showed is making this work, right? It's counting these, and you cannot change the outcome of that function because it runs on our servers. Okay, we're almost ready for the final round. The final is JavaScript versus Dart. Let's see where we get now. Honestly, this is an interesting pairing because I expect these to be really close. And guess what? These are the 2 languages that we've been programming today. So I like that too. Now, you might be wondering, how are those rounds created? Well, that's not a cloud function that we built. And we'll share the code for that and everything else we've shown you today in a repo on GitHub in probably the next week or so. Honestly, we just need to clean it up a tiny bit, but the code that you're seeing is all going to be shared, including for the web app that you've been using, including secure tools that we have running there. Okay, so honestly, it really looks close. Dart is getting a bit ahead now, but you can see that this is almost like a tie. As I said, we have no end to this, but we do have some more questions prepared. Let's see, how about, I'd like to know, what is your favorite Google technology of these 8? Okay, so these are 8 Google technologies. They're all pretty popular. Sorry, I just dropped something. And let's see what's most popular. Is it Firebase, Google Maps, App Engine, Android, Assistant, TensorFlow, BigQuery, or Flutter? And all these pairings, right, you're seeing one of these, and you're picking one. In the final, we're all going to be seeing the same one. In round 2, it's Firebase versus Android and TensorFlow versus Flutter. Now, honestly, these are all great technologies, so I won't be hurt no matter what you pick. But we can see that we have 2 clear leaders here so far. While Android had an early start, Firebase and Flutter are now definitely picking up steam. And it looks like we're going to get a final of Firebase versus Flutter. And Paul, definitely cast a vote on our mobile app wherever you can. Oh, this one is interesting. Because honestly, between the 2 of these, this is like peanut butter and jelly, right? These go together so well. So I have no favorite. I'm just going to sum these numbers in my mind and see them as a total vote for the combination of Firebase and Flutter. It's an awesome combination for building scalable, serverless, cross-platform, real-time apps. Okay, Firebase is winning. Thank you, but as I said, I wouldn't be offended by any other result. I see we have a few more minutes, so I'm totally gonna sneak another poll in here, which is, let's see. So this was Google technologies. How about we do other technologies that happened in, I think, the past 50 years or something. So 3D printing, cloud computing, iPad, Uber and Lyft, Alexa, Siri assistants, so all the assistants, iPhone, machine translation, or GPS. These are what I consider breakthrough technologies. And I want to know, what's your favorite? What do you think was most impactful for you personally? And you can see that in round 2, we're now getting cloud computing, Uber and Lyft, the assistants, and GPS. Let's see which are the most breakthrough for me. I was asked this question a while ago, and back then Google Maps was for me one of the main ones, but that might have been a while ago already. So these days that might actually be GPS, right? So, okay, I think we're getting ready for the final round, and it's going to be cloud computing or GPS. And honestly, both are all 8 for breakthrough technologies. This is really cool to see. I see cloud computing, and I'm not surprised. And of course, as a Firebase engineer, thank you. But that's really cool to see. I love that. Okay. I think we have a clear winner here. This is awesome. I have one more question. It's a question that honestly is top of mind of me every day, because I grew up watching a lot of Sesame Street, and I'd like to know, what is your favorite Sesame Street character? We have 8 popular characters here, and I want to know which one you like most of these. Let's see. But we're doing fine. But I'm not sure how we paired these up, Paul. This is really cool to see. But let's see who we get in round 2. The first round is always a bit of a knockout round, right? We get rid of half of the candidates. But now we get Elmo versus Cookie Monster and Count von Count versus Ernie. I love the Count, I must admit. But I like all of these. Also, Cookie Monster, as a web developer, has a special place in my heart, of course. Do you eat cookies? Let's see. So we have 2 leaders here, and it's not close. So in the finals, we're going to get Cookie Monster versus Ernie. That's an interesting pairing, I must admit. Let's see who's winning here. And Cookie Monster is the very clear winner. I am not too surprised about that. That is really cool to see. Thank you so much for telling me who today is our favorite Sesame Street character out of these 8. Thank you. Let's switch back to the slides to take us home. So you've joined the demo in droves. Thank you for that. And you could see that we dealt with that without any issues. We had no hiccups beyond some maybe coding mistakes that we made, but the database worked great. And let's see, how long did it take? We took like 50 minutes and we built the entire app. That's actually pretty cool. Let's see what we did, Paul. We have a few moments left. So we started with a Hello World Flutter app. Then you added 2 buttons to it, right?
Yep.
That's pretty cool, right? And at that point, the buttons were hard-coded. Then we actually started writing to the Firebase database. So we pulled all the configuration, right? We had a Firebase project in the console. We pulled our configuration from there, and then we added it in our Flutter app. Then we started writing to the database. That was good, but we needed to sign in. So we added Firebase authentication, right? So you use that to add serverless secure sign-in to your application. This is the amount of code it takes. I've recently actually added Google sign-in and account linking. It wasn't that much more code. Then we started writing that in the right location, right? So we changed the path and location. Remember, it's a JSON database. You determine what goes where. But you secure all of that with security rules. Remember, along the way, every step was secured. We showed you the rules. Let's see, what did we do then? We made it dynamic, right? We started listening for the values that we got from the database. And we wrote those options in the database, and it was auto-updating. For me, this is still the hidden magic of Firebase, because it allows us to make reactive applications. And then we started doing the votes in rounds, right? We made sure that you could have multiple rounds, that we would read them from the latest round, and show those votes, and do the casting. Then Paul explained to us how we can automate some of that with admin scripts, and how we can run automatic mini scripts on Google servers in Cloud Functions. That means that we can do operations that otherwise you can't do from the client, right? Like the code that does the total counting has to be trusted code. You can't leave that to the client. We did that in Cloud Functions. And we showed you that you can do much more magic with Cloud Functions. Paul, I'm actually pretty impressed how far we got. Did you find any big problems in the app we built?
Nothing that I could think of. It seems to be doing pretty good.
Yeah, I think so too. And this is definitely an app that I could see myself using in, I think my next meetup is on Saturday. Are you going to be using this going forward?
Probably, yep.
Yeah, it's fun, right? I really like this. So when is your next talk, actually? I was wondering about that.
I actually got a weekend off this time around. So it'll be the next weekend after that.